Good day to you. Welcome to Say Hi. So, this is the online training for March 8 to 12 for the subject Digital Basic for Batch 12. Okay? Our topic for today is about the decimal to binary. That means we will convert decimal into binary number. Okay? How could we do this? So by this samples, you will realize how to convert these decimal numbers to binary. By the way, so we have to identify first what is the decimal number and binary number. As a sample, I have given you the lectures for the decimal numbers, which is, for example, 18. Okay, the number 18 composes of 1 and 8. That means the decimal number, this composes of 10 and 8. Once 10 and 8. So this becomes 10 plus 8 is equal to 80. Okay, so way back in our lectures with the decimal numbers, we have about 10 figures. Those figures are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So completely 10 figures. So with these binary numbers, there are only 2 figures that we need to give. So what are those figures? So binary numbers, we have 1 and 0. Okay? So 1 and 0. It represents the number for 1 and 0. What is this? What is the purpose of these binary numbers? Usually, this language is composed for communicating the machine. As we say, in every book, machine is the very cruel and very, we have small brain. He is very simple because he has only two things to answer. Okay, for example, if he says yes, he will give number 1. If he says no, he will say 0. If he says off, he says 0. If he says on, he says 1. Okay, so these are just the numbers for the binary and decimal. So I hope with this past lesson from the decimal and binary, you will recognize. Okay? So now, we will go back to our topic for today, decimal to binary number. So how could we be able to convert this decimal to binary number? Okay? In the procedure of the conversion from decimal to binary, we have to decide, we have to divide, for example, 10. Okay? Okay, so we have to give around 10. We will divide the number by 2 in order to convert the decimal number into binary. How could you do that? Okay, so we will just simply divide the number by 2. Okay, let's see. Okay, as long until this one comes to the lowest number. Okay, let's do it. 10 divided by 2. What is the answer? Okay, the answer is 5. Okay, do you have any remainder? we do not have remainder. So if the remainder is 0, you just simply add 0. So there's no remainder with it when you cut 10 into half. There's no remainder. Okay, what about 5? If I divide 5 by 2, what is the answer? By using the calculator, you could able to get the answer as
2.5.
2.5. But do not include 0.5. Just put here 2. But instead, you will put the 0.5 as a remainder 1. Okay?
Remainder 1.
So, remainder has a significance in doing the binary. Okay? If you see in the calculator is 0.5, you just simply convert it to remainder 1. Okay? So, remainder 1. So now, again, divide 2 by 2. How much? Okay?
1.
So the answer is 1. Do we have a remainder? Okay? We do not have. So we will just
0.
simply add 0. Okay? Then, let's try again. Maybe we still have another one. 1 divided by 2.
1.
Okay? What is the answer? 0.5.
5.
But by that mean, you will just simply add 1 as remainder. Okay? When you get these results, by this, you will write the number or the answers like this one. You will take all of these remainders. Okay? From writing from down to up. Then you will write from left to right. Then how you will do it? Okay? 1. Okay? 0. Then
1.
1 and
0.
0. Okay? This is. Okay, so this is now the answer for decimal number into binary number. Okay? This is how we convert binary. Now, how could we check if our answer is correct? Okay. By the way, before we get here, I will explain to you again. How would we able to count by using the binary number? Okay? It is also our past lesson. Okay? Anyone who could give the numbers, for example, how we can represent the number 1 for the binary number? 1, this is for the decimal. So, we could able to, okay, by the way. Okay, see, 1 for the decimal. This is for the binary. Okay, for 1, it is 1. How about 2? How could we get the number 2? To get number 2, we have to say 1 and 0. Okay? How could we get 3? To get 3 for the decimal, we have to get 1 and 1. Okay? 1, 1. How to get 4? To get 4 is 1, 0, 0. Okay? Okay. How to get 5? To get 5, any guess? What's the answer? Okay, you are correct. So, to get 5, you have to get 1, 0, and 1. How to get 6? To get 6 is 1, 1, and 0. How to get 7? To get 7 7, correct? It is, okay, 1, 1, and 1. Okay? How to get 8? To get 8, any guess? Any guess? Okay? Correct. Okay? The answer is 1, 0, 0, 0. So this is how we convert. Okay? Now, what do you observe with these numbers? 1, 2, 3, 4, 5, 6, 7, and 8. We didn't use any numbers other than 1 and 0. Okay. What shall we do? Okay. So on this conversion, you will see that each of the positions has its value. Right? You get it? 0, okay. There's no value about the 0. But once it is placed on the right side of the figure, it will give significant value on number 1. But if it is placed on the left side, there's no significant value. Okay. So this is how we get the numbers. Now, go back to this. So, by using this value, we will check what is the number for this one. Go back here. How to get 10 to this decimal number 10 cents. Let's see. For each number, we have here I already prepared this one. Okay. So this one is, yes, okay. On this part, the value is 1. So once I put here number 1, so it counts as figure number 1. So on this side, if I put here 1, so that 1 here, binary, has the value of 2. And the one having here, on the third binary, it gives the number 4. And the last one we have here, it has the value of 8. Okay? So, as you observed, it doubles. It's just double to the next. Double the numbers. Double the value. Okay? For example, starting from 1, double number 1 is number 2. Double number 2 is 4. Double number 4 is 8. And so on. Okay, now, how can we come up with number 10? How can we come up with this? So, in this case, so we got number 8 for the 1. And number 2 as 1 again for the binary. So let us verify. So if this 1 has 0, so there's no value. If this 4 has 0 here, so there's no value. So that means only 8 and 2 has value. Let us see. So if it is 8, then 2, what is the total? It is 10. So meaning our answer is correct. Okay. I have a presentation. This is the method on how to convert the decimal into binary number. Okay. If I have here 24 trees, we will divide the numbers until it gets the binary number. Okay. 24. Out of 24 trees, I need to divide it by 2. Okay, so you will see here 24. So 2, 4, 6 times 4, 24. Okay, divided by 2. So I put it half. I put a line in the middle. Okay, so what is the answer? The answer is 12. Okay, so do we have any remainder here? No. Okay, correct. So I will just simply write our remainder 0. Next, if I have here 12, which is I cut a while ago, then 12 divided by 2. Okay, so what is the answer? Correct. I just write this line between the two in order to cut into half, equally half. Okay, 6. The answer is 6. So equally divided into 6. So the answer is 6. Do we have remainder? We do not have. So we will just simply write our 0. Okay. So 3 again. I will cut into half. Okay, by the way, 6, sorry. 6 divided by 2 is equal to 3. Okay? So, do we have any remainder? We do not have. Okay? So, we will just simply write 0. Okay, now, I have here 3. Now, I need to cut into half. So what shall I do? So I will put the line in between. But you see, I am going across one here in the middle. So that means I have a remainder. So if I have to cut this one in your calculator, it will give a result of 0.5. Instead, you will just simply write remainder 1 here. Okay? Then 1. 1 divided by 2, but still it will give a result of 0.5. Instead, what you will do, you will just write R1 as a remainder. Now, so that means once it reaches number 1, that means that the process is finished. Now, you will write the answers for the remainders from down to up, from the top. From down to the top. So the answer will be 1, 1, 0, 0, 0. Okay? 1, 1, 0, 0, 0. Now, let us verify. Okay? Let us verify if our answer is correct. So, for this value, this is 1, 2, 4, 8, and 16. Okay? So, but if you see, these 3 numbers doesn't have any value. So, other than 16 and 8 has the value. So, how much is 16? Then the other one is 8. So now, how much is this? This is equivalent to 24. So that means they have the same answers. That means it's correct. Okay? Next example. I have 8 flowers. I need to divide 8 by 2. So what is the answer? Correct. The answer is 4. Do we have remainder? Yes, correct. There is no remainder, so we'll just write R0. Okay? Now, divide 4 by 2. Do we have remainder? Correct. We do not have remainder, so we'll just write R0. Divide 2 by 2. So 2 divided by 2 is equal to 1. Okay? Do we have remainder or do we have 0.5 in our calculator?
Yeah.
Okay, no, we don't have, so we will just simply write R0. Okay, now 1 divided by 2. Okay, do we have remainder? Yes, we have 0.5 in your calculator. Okay, so instead of that, you will simply write R1. Okay, R1. So when the number is 1 already, that means the process is finished. Okay, again, write the remainders from down to the top. So the answer will be 1, 0, 0, 0. Okay? So 1, 0, 0, 0. Now let's check again. If our answer is correct. 1, 2, 4, 8. So that means the representation of the binary number into decimal number are equal. Okay? That means our answer is correct. Okay. So, did you find the procedure easy or difficult? Okay. So, this is just easy. Okay, but in some cases, that these numbers seems big. Okay. How if we will be involving big numbers and it's very hard for us to calculate? That is a big problem. Okay, we will be using the calculators. Okay, so there is another technique I would suggest. By using this table, okay, you can use this so that you can easily be guided on the value of each binary numbers. These are this 1, 2, 4, 8, double 8, 16, 32, 64, double 64 is 128. 128 double 256. Double 256, 512, and so on. So you already have this table. Okay? So, how if it's difficult? We have big numbers. Okay. For example, I have to get around 600. And since 600 is so big, right? Okay. So, what shall we do? Okay. Do you find some solution on how to convert these numbers, these decimal numbers into binary easily? There's another way. How can we do this? Okay, so this 600, we will just compute. Please compute for yourself. This is another technique. So in which, okay, anyway, which one is easier for you, you can use it. Okay, I have another suggestion for this. Now, this is how we will do it. If you will see this value, these are the numbers. Okay, out of 600, you will search for the number which is nearer to 600. But it will not exceeding 600. What is the number? What is the number? So, 512. Correct. Okay? So, this is 512. I will write here 512. Okay? Now, by this, until it gets 0, you need to complete this 600 out of this value. Okay? So, what you will do is to subtract these numbers go from the 600. Okay, this is what you will do. So how much now is 600 minus 512? How is it now? How much? 600 minus 512. How much?
Minus 512 equals 88.
Okay, so we have 88. Okay, we still have 88. Now, search for this 88. Look for the number less near to 88. What do you see? So this is 64. So you write 64. So 88 minus 64. How much is 88 minus 64? How much?
24.
Okay, so we have 24. Now, out of 24, which one is near to 24? So 32, do you think 32 is good? It is not good. So
16.
instead, we will be using 16. So 24 minus 16. How much? Okay, so this is
8.
8. Okay, so out of 8, now we already have the 8. Okay, so we will just simply add here
0.
8. Okay, so that means now this is 0. So that means the 600 is complete out of this one. Now, let us check what is the binary number using this 512, 64, 16, and 8. Where is 512? This is, if there is something here you use for the 512, you need to add 1. Okay, from here, starting from here, do not skip any of this. If there's nothing, no value for this, you will just simply add 0. If you use that value, so you will use 1. Okay, in 512 you use 1, correct? 1. In 256, 0. In 128, 0. In 64, yes. In 32, 0. In 16, yes. Okay. In number 8, 1. I use 1. 4, 0. In 2, 0. In 1, 0. So now this is the answer for 600. 1 0 0 1 0 1 1 0 0 0. Okay. If you would like to calculate, so out of 600, 512, 64, 16, and 8. So this is another way of computing the decimal to binary numbers. I have prepared here also the table on converting the numbers. Okay. So this side is for the binary number. Okay. There are 4 bits. 1, 2, 3, 4. Then these are the figures in decimals. So I have prepared here the figure, for example, 1. The numbers 1, 2, 3, 4, 5, and so on. For number 1, for the place value 1, I put here 1. Okay? But if you put 2, so this comes the value number 2. If I have 5, I have here number 5. Okay? You will see here on the table. If I have to use 12, so you would use 12. Well, how will I use the 12? I use 8 and 4. That's why we have 12. How to get 14? Okay? To get 14, you have to get 8 plus 4 plus 2 is 14. Okay? So this is how we can get this value. Okay? By this table, you can easily convert the binary to decimal and also at the same time decimal to binary by just simply looking at the tables on the column. Column is for the value of the binary numbers, then this one's for the decimal. Okay, these are the decimal. Okay, so you can use the numbers. Okay, so by this one, by this guide, you could easily see the value of each decimals without dividing the numbers by 2. For example, there are cases that the numbers are big, so it's difficult for us to divide the numbers 2. Okay, so we will just using this table to be able for us to help, and it's easier for us to do the process. Okay, I hope that you could help this procedure in converting this number from decimal to binary.